In this video, we want to determine certain features of a function given the graph of that function. And all we're given is the graph. We're not exactly given the function in terms of function notation. In other words, we're not given f of x is equal to whatever. We're just given the picture. And we want to use that picture to determine the domain, the range, the x-intercept, the y-intercept, or intercepts, and the f of 0 and the f of 2. So let's start out with the domain. Now the domain is basically the indication of what our x values are. In other words, what all input values are present with this particular function. If you're given the graph, a way of looking at this is it's how far to the left does the graph go versus how far to the right does it go, essentially. Because when you're doing domain and range, you want to put your answer in terms of interval notation. So again, domain is going to be x values. So you want to answer it in terms of x values. So one good way of visualizing what the domain is if you compress the graph onto your x-axis. In other words, if you pressed it down from the top into the bottom, how much of the x-axis would it cover? Another way of asking that question is how far to the left to how far to the right does it go? So for this particular problem, this lower section down here, the section looks like a diagonal line going to the bottom left, we want to ask ourselves how far to the left does that go? Well, it keeps going to the left forever. It keeps going down, but it also keeps going to the left. And so if you ever have a function that goes to the left forever, your starting point, quote unquote, is always going to be negative infinity because it never stops moving in that direction. And of course, that's not really a starting point because infinity is not really a number. It's more of a direction that you're heading in, I guess you could say. So now we go how far to the left to how far to the right. So when we're talking about our x values, we want to know what's happening as we move further and further to the right. And so we're going to look at the upper right-hand corner, this part of the function that's really half of a quadratic, and we want to ask ourselves, how far to the right does it go? Well, again, since we have this little arrow at the top, we're going to continue going to the right forever. Now it goes up, and it gets steeper and steeper, so it goes upward much more quickly than it goes to the right, but it still goes to the right forever. And if that's the case in any problem, then you're always going to put positive infinity for that part. So again, domain, ask yourself how far to the left versus how far to the right. And you put those two numbers in interval notation. So now let's talk about the range. Now the range is going to be our y values. And so your answer is going to be in terms of the y-axis. And so just like with the domain, you could compress the graph from top to bottom onto the x-axis. You could do the same thing with the range if you wanted to visualize what your range is. You could compress your graph from left to right onto the y-axis. Or another way of asking the question is how far down to how far up. Now, when we're talking about our y-axis, you can notice that we have this little gap right here that I just marked in green. So that gap is going to be something we need to take into account. Really, we're going to have two different intervals that describe the possible y values of this function. So we're going to start out by looking at the lower left-hand part, and we're going to ask ourselves, how far down does that go? Well, we already talked about it always goes to the left forever, but it's also going down forever too. So we're going to say negative infinity for that part. And we want to see how far up, or what's the largest y value that we have on this lower part that I'm pointing to in red still. Well, the highest y value, or the greatest y value, is -4, and that occurs right here. So how far down to how far up? But notice we have a hole right there at the -4. So we're going to include the value -4 when we write this down right here, but we don't include it in the actual interval notation. So that's why we put a parenthesis right there, because that value is not there. We get infinitely close to it, but we don't quite get to the -4. So now that tells us the first little chunk. So that's taken care of. So now we need to worry about the other part of the function on the other side of that gap that I just erased. Now we're worrying about the little half quadratic part. So again, we want to ask ourselves, how far down to how far up? So the lowest value that we have in terms of the y-axis on this section is 0, because that we have a dot at the origin. So this time, instead of a parenthesis, since it's not an open circle, it's a closed circle, we're going to include the value 0. So we're going to put a bracket around that. So anytime you include a value, in other words, a solid circle, you're going to put a bracket. Anytime you're not including a value because you have an open circle, you're going to put a parenthesis. You also always put a parenthesis around negative and positive infinity. So that's the lowest value of the upper section of this function. So now how far up does it go? Well, it keeps going upward forever. And so that's why we're going to put infinity, because there is no stopping point. So our range for this function is negative infinity all the way to -4, and that would be visible right there. And then we're going to pick up at 0, and we're going to continue toward positive infinity, and that's where that upper section, where we're getting that from. So now let's talk about our x-intercept. An x-intercept is really, it's kind of exactly what you would think. It's just where the function runs into the x-axis. So we're interested in all the places that it runs into our x-axis, which I just marked in green. And so the only place that we run into the x-axis is at the origin, at the point 0, 0. So we can say the x-intercept is 0, 0 if you want to do it as a point, or you could just say at x equals 0. That would be fine too. The y-intercept, we're going to look at it the same way. We want to mark all of the points, or take note of all the points where we run into our y-axis, which I just marked in green, the vertical axis. The only place we actually run into the y-axis is at the origin again. Remember, we have the open circle at -4, so that's not technically a value, it's not an intercept. So we're going to have a y-intercept at the point 0, 0. And that's that. So now let's look at the function values. We want to evaluate the function at 0, and we want to evaluate the function at 2. So the big thing to remember here, when you're doing this so you don't get confused, is if you have the f of something, whatever that number is, that's going to be an x value. So what you're looking for is you're looking for the corresponding y value. If you're given f of x is equal to, and then you're given a number, then that means you're given the y value, and you want to find the corresponding x value. So just kind of keep that in mind, it'll keep down the confusion. So the f of 0 means we want to go to 0 on the x-axis. We can put a mark, and then we want to know what the y value is at x equals 0. So you go up or down until you run into the graph, actually. Well, it just so happens that we run into the graph at that point, because we do have a value of 0, 0 at the origin. And so the f of 0 in this case is going to be 0, because the y value associated with the x value of 0 is 0. Now the f of 2 will be slightly more interesting. So we're going to go over to the x value of 2, and then we're going to go up or down until we run into the graph. You can see we run into the graph. Right there, I just made that dot red. And so what we want to know is we want to know what the y value is of that point, and the y value is 4. And so the f of 2 is going to be equal to 4. And that's it.